Alrighty, YouTube. We're going to continue on from where we left off the last time. I actually skipped some algebra questions, so we're going to do another part with some algebra questions. The next algebra question is number 68. It's slightly tricky, so I would kind of categorize this as a non-easy question, at least in the realm of SHSAT questions. So let's go through it. The cost of shipping a package is $12, okay, plus $2 for each additional pound over 3. Okay, which expression represents the total cost in dollars of shipping a package that weighs p pounds? Assume that p is greater than or equal to 3. So let's just try to do a model kind of first, which is that it says the cost is going to be $12. So that's basically a flat fee plus $2 per pound. And they're saying it weighs p pounds, so we're going to use p here. And the cost is going to be in dollars. All right, so the cost is equal to 12 plus the 2p. There's a problem here because if p is greater than or equal to the 3, we're okay. So 4, 5, 6, 99. But if it's 1, we can't plug p. Let me change the color here. We can't plug a value of, say, p equals 1 into there because that's not what the English is saying. We can't come here and do 2 times 1 and get 2 and then plus to get 14. That doesn't work. Okay. So just to be clear, if the package is 1 pound, the total cost is $12. Right? There's no $2 each additional pound. There's no additional pounds because it's 1. If it's 2, it's going to also be $12. Okay, and this is kind of how the U.S. mail works and other things like that. If it's 3, again, it's not over 3 pounds. It's equal to 3 pounds. So at that point, they're telling us it's going to be 12, right, plus $2 for everything over 3. Okay, so because it's telling us what represents the total dollars of the shipping package that will pay p pounds, assume p is greater than or equal to 3. So what we need to do is adapt for this scenario from this point forward. So basically, if we have 4, right, we need to accommodate for that amount there. Okay. So if we kind of work it through, that basically we're trying to sort of change the equation to cost is equal to the $12 plus 2 times p greater than or equal to the 3. Okay, so this becomes the awkward part. How do we figure that out? Okay, well, if we just use the table that we just drew here, we can see that if we subtract off 3 from each value, right? Because if it's 2, it's only $12, so we don't care about it when it's under the 3. All right, so that would give us $12 plus 2 times p minus 3. So in this case, if we have $4, right, we're going to add $1 to it. So that is the expression there that we need, and then the answer here would be F. All right, so this does get tricky. It is a weird question. That's what makes it kind of hard. Yep, the answer is F for that. And you just have to try to rip it apart. It has this little nuance, which is how do we deal with p being greater than or equal to 3? We just kind of do the magic and subtract it, right? So, and the question, you could say, well, how could it be F if pounds is 1? It's telling us this assumption has to be part of the question, right? It says which represents the total cost that weighs p pounds, but they're only asking 1p is greater than or equal to 3. The question is not asking 1p is less than 3. All right, so we're cool. That means it's just F. All right, and that little nuance gets you. So there's 2 issues. One is realizing the question is only asking for the expression from 1 is greater than or equal to 3. And the other nuance is, how do we map this over here into an expression? It's just, we just subtract it at that point. We're not caring about the cases where it's less than 3. So it just falls into place. Okay, that's 68. 69 is an equality. I think 112 or 113 was the last one we did at the end of the other one. And that was it. And by the way, hopefully my mic is better here as well. I had a mic problem in the other one. I didn't realize it when I was doing the stream. It sounded like I was in a phone booth with a weird echo at the end of it as well. In any event, Julie is at a clothing store. Awesome. She wants to buy a bag for $18.75 and some t-shirts for $9.25 each. So we don't know how many t-shirts. So this is basically a question mark. Or we could say she's going to buy X t-shirts. Now, I noticed some of the answers have X's in there. I don't know if they're using the X in the same context. So let's kind of try to figure that out first. Okay. She can spend no more than $50. So she can spend up to $50, which inequality can be used to find the number of t-shirts X. So that X is the sum, not SUM, but SOME. What is the number of t-shirts that Julie can purchase? So if they're $9.25 each, right, that pretty much off the bat rules out this here and that there, because it's $9.25 times the number of t-shirts. Okay, and then she wants to spend no more than $50, right? So it's the $18.75. It told us she wants to buy a bag for $18.75 and t-shirts. So that's C. All right. She wants to buy a bag that's worth $18.75. She's going to buy a certain number of t-shirts that are $9.25 each, and X represents the price, the number of t-shirts, sorry, and that she has at most $50 to spend. So there we go with that. And the next one, I think, that was a algebra question, was 107. And just be careful with your inequalities. Whoops, we just skipped that. Okay, so I like to look at something like this as an actual illustration. So it says P, which is probably the price of something, is $2.50 plus $1.25 times the number of C's. All right, so there's really nothing else to grok out here. It's a linear equation. It's y equals mx plus b. Basically, that's y equals mx, and that's the b plus mx. Okay, so we may or may not really care that comes into play, but it's kind of good to know what some of the underlying concepts of these things are. It's better than kind of good. It's essential often. So let's see what this means in English. This is the math. So let's go back up to the top and see what it means in English. A bakery charges $1.25 for each cupcake, okay, and $2.50 for the serving tray. So let me just change the color so we can kind of write some stuff out here and try to get a sense of the math in English. So the cost is equal to $2.50 was the price for the serving tray. So it's going to be the tray plus $1.25, right, times the number of cupcakes. So that's kind of, we're just trying to feel out the expression and understand it. If Samantha bought some cupcakes, so this is almost the same language we just saw. So she bought X cupcakes. In this case, they're telling us it's C, the price of C cupcakes. So the sum cupcakes is going to be C. And a serving tray for a total of $22.50, not including tax. So we don't care about that. How many cupcakes did she buy? All right. So we have $22.50 using the equation. We have the total cost is equal to the cost of the tray, which is $2.50, plus $1.25 times the number of cupcakes. It's just that simple. We're going to subtract $2.50 from both sides. That goes away. Subtract $2.50 from here. Okay. And we should end up with $20 equals 1.25C. Divide both sides by 1.25. That goes away. Divide this by 1.25. We could actually do that, or we could realize this 1.25. So we get 20 divided by 1.25 is 1 1/4. Whoops, I wrote 1 1/5, so that's the same as 20 divided by 5/4. And this is the classic problem we just solved a number of times in the other videos. If we rewrite that longhand, we get 20 divided by 5/4. Okay, and that's the same as multiplication by its reciprocal, or keep, change, flip, keep the 20, change the operation, and flip the fraction. So 5 goes into here 4 times, and we get 4 times 4 is 16, and the answer for that should be C. Okay, that was what, 107? Yeah, 107 is C. So it's just a matter of realizing it was a linear equation, following that model, plugging in the right numbers. Really, it was just key to 2250. They gave us the expression here, so all we're doing is 2250 is equal to that. And at that point, we're solving for C. C was the price of the cupcakes, the price of C cupcakes. So C is the number of cupcakes. So that was what was, how many cupcakes did she buy? So we set up an equality, which was similar to the inequalities we just solved. Okay, I believe that's the last raw algebra, and there is questions that mix them back and forth, but I'm going to end this video here. We did 3, and and this question here is not too bad either. It's just a matter of plugging in. The words almost distracted from the equation, if you will. If they gave the equation and said how many cupcakes, C represents the number of cupcakes, you could just do it. So it's just a matter of doing stuff like that. All right, y'all, hit me up, GregsTutoringNYC@gmail.com. Please like and subscribe and share and set your notifications and comment, and live long and prosper. Peace out.